In this video, I'm going to solve this optimization problem. So I've got two cars. I've got car B, which is 30 miles east of car A, and car B begins moving west at 90 miles per hour. So let's put car B there at time t. And then at the same time, that car which started out here starts moving north at 60 miles per hour, and that's car A. So let's say at time t that car A is right there. And we would like to minimize the distance between the two cars. That's this distance here. Now I can see that I've got a right-angled triangle. So it would be good if I could represent this distance and this distance. So let's see. Let's let t be the number of hours they've been traveling for. And so after time t, this distance traveled, because B is traveling at a rate of 90 miles per hour, after t hours, that distance will be 90t, which means that this distance will be 30 minus 90t. And on the other hand, car A is moving at 60 miles per hour, so after t hours, this distance will be 60t. And I want to minimize z, and I know by the Pythagorean theorem that z is equal to the square root of 60t squared plus 30 minus 90t squared. But as we discussed in class, it's better to work with the square of the distance, and in fact, the value for t that minimizes the square of the distance will also minimize the distance. So let's call that d of t. And so I'm going to get rid of that square root. And instead, I'm going to minimize this. And I'll have t in the interval 0 to infinity. And so this is what I'm going to minimize. And so to do that, I should first find my critical number. So let's go ahead and take the derivative. So we'll use the chain rule. And so when I differentiate, this is what I get. And I'm going to simplify that. So I've gone ahead and I've simplified, and that's what I get. And now d prime t will be 0 when t is equal to 2,700 over 11,700, which is 27 over 117. Both are divisible by 9, and I get 3 over 13. Now, I should show that that actually gives me a minimum, and to do that, I would like to use the second derivative test. I could also use the first derivative test, but I know that it's really easy to take the second derivative. So d prime t, if I take the derivative of that, I get d prime prime t. That is equal to 2 times 11,700. And if I evaluate d prime prime at that critical number, I get exactly that. And that is certainly greater than 0. And so that tells me right away that that's a minimum by the second derivative test. Okay, so I've gone ahead and written that down, that by the second derivative test, this gives me a minimum. And I'm asked after how long the minimum distance occurs. Well, that's 3/13 of an hour. So 3/13 times 60 is equal to 180 over 13, which is approximately 13.8 minutes. So to conclude, the distance is at a minimum after 13.8 minutes.